Hello, this is question 10 on your June 2020 or November 2020 paper from Edexcel, the AES paper. You have this function here. You have to use the factor theorem to show that gx is divisible by x minus 5. Remember, the factor theorem tells you that if g of 5 is 0, x minus 5 is a factor. Which means if x minus 5 is a factor, is because g5 is 0. So what we have to do is to check g5 and see if it's 0. Yeah, we have to check that. So we substitute in gx x by 5. So we have 5 to the power of 3 plus 5 squared minus 41 times 5 minus 70. And this is 0. Yeah, you can just check with the calculator. So as this is 0, x minus 5 is a factor. Yeah, we can say then for b it says hence, so using that, so we know you're working, write gx as a product of three linear factors. We know one factor already. If we divide our function by this factor, we are going to get a quadratic function. Yeah, because the degree will go down by 1, and we know how to factorize the quadratic. So we are going to do that. We are going to divide the polynomial, find a quadratic, and then factorize the quadratic. So I'm going to divide the 2x cubed plus x squared minus 41x minus 70 and get a quadratic. So we have 2x cubed divided by x is 2x squared. We multiply and we have 2x cubed minus 10 times 5, which is 5 times 2x squared is 10x squared. We subtract, so these two are gone, and then I have 1x squared minus 10x squared is 11x squared. I divide 11x squared by x, which is 11x. Multiply again, so 11x times x, 11x squared. 11x times minus 5, minus 55x. And I subtract. These two are gone, and then I have minus 41 minus 55, which is 14, positive 14x. I divide again, 14x divided by x is 14. And when I multiply, I have 14x minus 5 times 14 is minus 70. And when I subtract, these two are gone, and this one with the plus 70 are gone as well. Yeah. If you don't get remainder 0 here, it's because you have done something wrong with the working out. Because when you divide by x minus 5, the remainder should be 0, and this is a factor. We know that. Which means gx can be written as the x minus 5, and then this quadratic that we have found. Oh, sorry, without the bracket, plus 14. This quadratic here, yeah, is this one. We are going to factorize this quadratic, and then we have it. So to factorize that quadratic, 2x squared plus 11x plus 14. Remember, when the coefficient is different than 1, I'm going to look for a pair of numbers that multiplies give me 14 times 2, which is 28, and added together give me 11. So I'm looking for two numbers that multiply together are 28 and added together 11, which is quite quick to find, is 7 and 4. So I'm going to write the 11x as 7x plus 4x plus 14 equal to 0. So I have, well, not necessarily equal to 0, I'm just going to factorize. So I factorize this bit and I factorize this half. Yeah, so I'm splitting the 11x in 2 and I'm factorizing this. The only thing I can factorize is the x. So I have x multiplying 2x plus 7. And the other I can factorize just divided by 2. So 2x plus 7. These factors are going to be always the same, which means I can write as 2x plus 7 multiply 2x plus 2. Yeah, I can factorize again as 2x plus 7 because it's common in both of them, and then x plus 2. So my function gx, fully factorized, is the x minus 5, 2x plus 7, and x plus 2. Yeah, and that's what they ask us in this part B. Yeah, product of three linear factors. The finite region R is bounded by the curve with equation y equals gx and the x-axis, and lies below the x-axis. Find using algebraic integration the exact value of the area R. I'm going to do a quick sketch just to show you what we are doing, because I think it is going to make more sense. Yeah? So if we represent gx, and we know how to because it's a cubic, and we know the factors, so the factors are these ones. When I find the roots to represent the cubic, one is 5, then I have another that is minus 7 halves, and another that is minus 2. So my roots are x equals 5, x equals minus 7 halves, and x equals minus 2, no? Yeah. And is coefficient of x cubed is positive, so my graph is going to be doing this. Roots are minus 2, no, minus 7 half is more to the left, so minus 2 and 5. So it's going to go up, and it's going to cross the x-axis here, here again, and in the 5. So it's going to do something like this. This is my cubic graph. They are asking me the negative or the area that is below the x-axis. Yeah, so it means this area here between the minus 2 and the 5. And those are my limits of integration. Yeah, so my area R, they call it R, is the integral between minus 2 and 5. Actually, I'm not going to write this because the integral is going to be negative, and I'm going to change the sign. So I'm going to integrate between minus 2 and 5, 2x cubed, I explain what I say in a minute, plus x squared minus 41x minus 70, minus 41x minus 70 dx. I integrate this function, which is quite simple, so I have 2x to the power of 4, x to the power of 4 divided by 4, so I can simplify the coefficients a bit, and I have 1/2 of x to the power of 4 plus x cubed divided by 3 minus 41 divided by 2x squared minus 70x between minus 2 and 5. And I'm just going to substitute. So I substitute the 5 to the power of 4 divided by 2 plus 5 to the power of 3 divided by 3 minus 41 divided by 2 x, 5 squared minus 70 times 5. And now I'm going to substitute the minus 2. So I have minus 2 to the power of 4, 2 plus minus 2 cubed divided by 3 minus 41 divided by 2 minus 2 squared minus 70 times minus 2. I wouldn't skip steps or brackets because it's easy to make mistakes with these questions. And now with the calculator, we can just find them. Yeah. The first bit is minus 1525 divided by 3, so it's a long number. And the other one is 190 divided by 3. And when we put them together, we have the integral. Be careful because they are asking us the exact value, so we are not going to divide, and the area. The area is not negative, cannot be negative. The area is always going to be positive, like the distance or the length. And what is negative is the integral. That's what at the end you have to write that R is that value but positive. Yeah. So don't write that the area is negative because it's not. The area is positive. What is negative is the integral. Yeah. And that's all with this question.